We saw in our brief introduction to functions f of x equals 2x, otherwise known as y equals 2x. So if I make a t-chart and plug in -2, -1, 0, 1, 2, 3, I get out -4, -2, 0, 2, 4, and 6. I basically double whatever goes in. My output is double that. So I plot those values, those coordinate points on my Cartesian plane here on my graph and my x and y axes, and I get y equals 2x. This is definitely a line, and we're not going to go into necessarily what makes a line here, except that our linear graph for us means that the slope is constant. And if you notice here, that's kind of what makes a straight line, right? And that if I have something that looks like that, well, that's not a linear graph. The slope is definitely not constant. So here, you may recognize this as y equals 2x plus 0, otherwise known as y equals mx plus b. In this case, m, or 2, is equal to the slope. And 0, or in this case 0, 0, is our y-intercept. 0b would be our y-intercept in the more general case. So if I go back to my graph, I can see that 0, 0 is where the graph crosses the y-axis, and that the slope is up 2 over 1, up 2 over 1, up 2 over 1. Same thing down here, up 2 over 1 if I'm going left to right, and the slope is constant. So our slope, I can write instead of 2 is 2 over 1. That's basically how I can graph anything in the form of y equals mx plus b. So for example, if I say y equals 3x, again, I have a y-intercept of 0, 0. I know that my slope is 3, which I can write as 3 over 1. I'd go up 3 over 1. Any 2 points will make a line, and I've now graphed this line, y equals 3x. So you might ask, well, what if it's y equals 3x plus 2? Well, my slope here is still 3 over 1. My y-intercept is 0, 2. So in this case, instead of going through 0, 0, I would be going through 0, 2. I would be going up 3 over 1. Again, between any 2 points, I can create a straight line, and I now have I've graphed the line using y equals mx plus b, using the slope and the y-intercept.